We are starting the recording for those people that are in other periods. Hello and happy Valentine's Day. Unless you're Amanda Padal, then happy Tuesday after Valentine's Day. Everybody else, we do have Chapter 7, Systems of Equations and Inequalities. If you haven't gotten it yet, in your Google Classroom, you have homework 7.1 up and ready to go, not only here, but also here. And there's some vocab, and then there's some solving, and then there's some, that looks fun. If I were you, I would have your graphing calculator open. It is not the main player. It's not the main player this chapter, like it was for Chapter 6, but every now and then it's going to be useful. As we get ready to go today, you guys should have already started notes. And what was, for those kids that were not in here, besides the fact that they should buy Krispy Kremes at Nutrition, and Lucas Sweet says he fully approves, besides that, what else did I talk about on this page to try to encourage those of you that are like, is there more trigonometry?
You said it's not that much.
I said there's not that much, if any. There's not that much, if any. And what did I draw your attention to as far as something from the past on this page?
We're doing that substitution problem?
Whoop! Well, maybe the title, but I think I drew your attention to this guy, right? And did I ask, or I believe I asked, does this look familiar? Yeah. Question, what are the unknowns in that system? Hold on, how do we know it's a system? There's an underlined word, system.
On top of each other.
Yes!
There's that little arrow thingy.
It's not an arrow, what's it called?
Bracket.
Nope.
Fake
Crown.
Nope.
Arrow.
bracket.
Some of you might have these on your teeth, or you might have used to.
What? Crown. I say crown.
That's more like older people on their teeth, or people with
Braces.
braces. It's a brace. Good.
Brace.
It's called a brace. It's like a bracket, but it's twisty curly. What? Oh, he said it. Not even. Bummer. Yeah, it's called a brace. There's technically only one. It's not on both sides. Only on one side. Okay, now that we all talked about our teeth, coming back. So with the brace, it's tying them together and saying, hey, they both need to be true. Why do you think it might be important in this situation that we have two equations? Why is that crucial?
So you can self-rely and make sure it's equal to 4.
Oh, because we have how many unknowns? 2. Do you guys remember from your introductory Algebra 2, maybe even Algebra 1, that you need the same number of equations as unknowns to be able to solve? So for 2 unknowns, we need how many equations? For 3 unknowns? For 4 unknowns? For 10 unknowns? Hopefully we're using technology by that point, right? Okay. Couple things. Are we all back? Cool. What are the vocab words that you guys see on this page, just as we started? System. So we have a system. And then what else? Solution. And then you could kind of say these guys, but aren't these more just descriptors that you should already know?
Ordered pair.
Linear would be of the form of a line. So I mean, I guess y equals mx plus b is the form, but shouldn't you guys already know that? But yeah, you're right, it is a term, but it says it's a linear system. Why is it a linear system? Well, question, what's the power of x? To the 1. How about y? To the 1. And what types of equations have y to the 1 and x to the 1? Linear. So that guy's linear, that's slope-intercept form, that's standard form. Do you remember this stuff from Algebra 1? Woohoo! What's Algebra 1A doing right now? Point, slope form, P.S. This is the one that is most important for calculus. Alright, coming back. But why is this guy non-linear? Yeah, he's definitely not that. I have a logarithm, or I have e, or I have the squared. I mean, the y is okay, but the ln would make it non-linear because there's a curve to ln's. E has a curve. Y squared must have some sort of... What does y squared look like? Like, let's say the e wasn't there and it was an x and a y squared. I thought x squared. What about y squared?
Don't have vertical line.
Switch the x and y and you invert it, right?
Yes.
So x equals y equals x squared, x equals y squared. The w, what are you guys thinking about with the w? The w
Equals xy squared.
is if you have an absolute value around like an x squared minus 5. That would be a w. What? How would that be a w? Oh, I just went from black to black. That's random. Why is that a w?
It's like a parabola.
It's a parabola, but it's a parabola that's been shifted what? 5 units down. However, can I have a negative number coming out of an absolute value? Nope. So what was 5 units down now gets thrown to be what? There's your W, cool kids. Technically, still non-linear. You're right, but it would have looked way different than what's up here. Okay, so coming back. So we have some descriptors. I don't think we need to define equations or variables. However, here's your system of equations. You guys see it? Systems of equations are multiple equations with multiple unknown variables that basically need to be true all the time, or that need to be true together. And a solution is an ordered pair that satisfies such an equation. Real quick, I talked about how, let's see, there are 2 equations, or I should say 2 variable systems. That would be like a 2-dimensional solution. What if there were 3 unknowns? What does a 3-dimensional point look like?
Oh, watch that video.
Ooh, an x, and a y, and a z. Ooh, could you have a 4-dimensional system?
X, Y, Z.
And a 5-dimensional system? And a 6-dimensional? You might stop using x's and y's and z's because you kind of just ran out of letters in the alphabet unless you start over at A and B and C. So you might do something instead like A1, A2, A3, A4, A5. You could do that forever. Letters will run out. Subscripts will not. But how do we answer that question over there, cool kids? If they're literally just asking, is it a solution? And a solution is an ordered pair that satisfies each, aka both, equations in the system. What am I going to do? Yeah, exactly. You don't even have to solve it. You're just saying, does it work? Well, does it work? Plug it in. And so when I plug it in, I plug the x into the x spot, the y into the y spot. Question, does 2 times 2 plus 1 equal 5? Nice. But is that enough to say it's a solution to the system? Nope. What else you gotta check? The other one. Guys, what order do we go in when we solve things like this? I guess, okay, what I meant was like once you have it plugged in. But yeah, you could try the top and then the bottom. Good. But once you're in the midst of this, Ryan Krikorian, what did you just say? PEMDAS. Which means multiply, then subtract my illegal algebraics. What's 6 minus 2? And it checks out. So therefore, is it a solution? Yes. Why? Since it is true in both equations. Does that make sense? That's just the basics. We're going to talk about these 2 in just a second, but Ryan, go ahead.
What was the sign, the angle? I don't know what you call it. It's like a bracket. It's containing 2 equations. It's on the
Equations? You don't mean like intervals, right? You don't mean like this?
No, it's in the problem.
Brace?
The brace, yeah.
Oh, you're just asking the name for it? Yeah, the brace. It's also what is shift bracket on your keyboard. Yes. But the brace. Oh, looks like brave. Do that too. Okay, so coming back. What's the solution going to look like for this one then?
It's just a line.
Well, they are 2 lines, right? But what's the solution going to look like? What am I solving for when I'm done? What should I have? What would the solution look like? I don't need the numbers, just what would it look like? Yeah, it would be coordinate, good, and it'd be some sort of x, y, if it exists. And how does that make sense of what we know about geometry? If it exists, how does it relate to these 2 lines? And how could I use my graphing calculator to find it?
I think it's because they both intersect.
If it exists, then they intersect because every solution is a point of intersection where they share common values. Does that make sense? So, if it exists, why am I saying if? Someone tell me a situation where two lines won't intersect. That's no intersections. And is there any other case where lines don't intersect in just one point?
You know, like the axis where it tries to
Step graph?
close to it.
But a step graph wouldn't be a true line. It's a collection of lines, but not a true line. And then Ryan, what were you saying?
So like the exponential graph, you know how like there's an axis and it tries to touch it, but it never does it. So, like,
Oh, so if we bring in curves, yeah. But coming back to the lines though, so let's say it's linear. But yeah, you're right, curves could just totally not be parallel, but also not hit because of an asymptote. But think about two lines. How could two lines not be intersecting in just one point? Absolute value would be two lines. So you're thinking of all the different ways we could have broken lines or like a collection of lines. However, right over here, Noah, what?
Oh, if they're on the exact same place.
No, they wouldn't have two intersection points or three intersection points without being broken, right? However, it's either one, none, or infinitely many all the time. Exactly. Well, unless they were in two different planes, then it's not parallel, and it's not intersecting, and it's not the same. It's something else. Remember the name for those lines? It is in the third dimension. But what would be non-intersecting lines that aren't parallel? They're in two different planes. Huh? I haven't heard it. No, perpendicular would be one intersection point, but it is a different relationship. You're right. What would this one be where they're not intersecting? They're in two different planes. Parallel is this way. What about this way? Yeah, like that. Starts with an S and ends with a Q. There it is. Skew. Yeah. They want to totally give it away. What? Rockstar. Okay. Oh wait, the Kirby one. Sorry.
What did you write under the is to want a solution?
Yes.
Oh, where?
It's true in both.
Yes, since it is true in both equations. I abbreviated. And I did my not want to pick up the pen. What I wanted to show with both of these, I guess we could say this. I'll leave it like this. Solutions are I know you guys don't like graphs, but technically if we were thinking about these graphically, we could say they are intersection points, and all of a sudden I remind you that I said sometimes we're going to want to use our calculator. We see this tying together, right? Sometimes we're going to want to use our calculator intersection points. Oh, that's a thing I could do on my grapher. Okay. Oh my goodness, our book makes substitution hard? All right. Substitution, you guys should know what it is. Well, you can simplify it a couple different ways. Some people say plug and chug. Sometimes I say that. Plug it in. You can do that too and sing the Glade commercial. But as far as the method of substitution, maybe you've never seen it written out because your Algebra 1 teacher taught you like the simplest version. We probably didn't go much more in depth last year in Algebra 2. But remember, your goal in one of the equations is to solve for one in terms of the other. And then the key part is to plug into the other equation. P.S. common mistake a lot of people make is to plug it right back into the same one they found it from. It's going to end up just being true and not solving for anything. I need to tie it all together. I need to keep it tied together. Solve one for one variable, plug it into the other. Solve that equation, and then, ooh, new vocab word. You guys got it? Back substitute.
Do I write this down?
That's up to you. But be careful. A very common mistake is that you don't plug into the other. Although some of you have this as a habit, I do want you to at least have the new vocab word of back substitute. What does back substitute mean? Back substitute means we just solve for one variable. we're going to go back to an expression. We're going to go back to that original equality, that original relationship that we used for our substitution. We're going to go back and substitute into that. So we're kind of going like full circle. We solve for one in terms of the other, plug it into the other equation, we solve, and then we go right back to where we came from, which is why both of these are boxed, to solve for the other variable. And then the one that most of us love and hate, love because we normally skip it, hate because sometimes we actually need to do it, and we just don't realize, is this step of check. Now, hold on. I know you love to skip the checking, but it is necessary for systems with any sort of limited or restricted domain situations. If there are any systems that you have, remember we have E's, we have LNs, we have trig, we have different things that could be showing up beyond just normal algebraic, like polynomial stuff. If anything in the system from the beginning has any sort of limited or restricted domain that says, I only accept these certain values, we have to check in the end that it is a legal solution. Because some of the math that we're going to do ignores the restrictions. And so little illegal answers sneak their way in. And it's totally in the legal math that we're doing. The legal math has us do the inverse of some of these operations, where one says, I only take certain values, and the other says, everybody's welcome. And then at the very end, you can have some issues. At the very end, you can have some issues. I'm trying to think of like a real life example. Maybe we'll try to do an example and then see if you guys can come up with one. Where like you have to go through like two different parties in order to actually get to, I'm trying to think of like tickets to like a concert or something. And like you go through a site or you go through a vendor to get the tickets, but then you still have to face the people at the front door. Maybe like for instance, yeah, maybe the movie theater, although they don't really check your vaccination card. I mean, this is a silly example, but it is true. Like when I went to a Clippers game recently. Like, you had to go through someone to get the tickets, but still at the front door, if you don't have your vaccination card, you're not getting in, right? Or at least back when I went. Yes, things might change, but that's not the purpose of the example. So the idea is you have to go through one person, but then at the end of the day, like you still might not get in, even though you have that valid ticket, because you have to make it through a few different levels. So you can maybe think of another situation as well. But it's like, I have the ticket, it should be good. Do you meet all the restrictions? Think about airline flights, you can think about different things like that. That might work too. Huh? What else can you think of? Chris?
6 months, you have to pay a ticket to get in, but if you're too short to ride a ride.
Oh yeah, you might not get on the ride. So maybe you're in the park, but you might not still be able to ride a ride. Hey, that's a good point too. Because you have to go through multiple. And that might, I was trying to think of like an age restriction. Like online, you might be able to like fib that you're over a certain age when you bought something, but then like when you get to the door, they might check your ID. Like you could do something like that too. Noah, what else?
Like you have to pay for the water bill, but in the end, if something like a sprinkler breaks or anything, you're paying for it still.
Oh, interesting. Like there's a flat fee, but it still could go up.
Yeah.
That's a good point too. So you guys can kind of like think of, I know it doesn't seem, you're just like, whatever, do the math and then I have my answer and I'm done. But it's like, no, life is complicated and some of these functions are more complicated than you've been used to. And so I know that this seems tedious. No, wait. I am trying to be very specific though. When do I say we need to check? I'm not saying if you have 2 lines you need to check. As long as you did your math right, you're good. Or 2 parabolas, or 2 polynomials. I'm saying you need to check if you have anything with restrictions. Okay, so as we get over here, there was like a little note maybe that could be helpful, but let's come on over to the first example, which says solve. How do you guys want to start? P.S. You have a choice. You just need to solve 1 for a variable. Put an E. What do you want to solve for, Jackson? What's your objective by putting an E?
Solve for X.
He's trying to get this x by itself, right, guys?
Yes.
But why are we all going to say, maybe not all, but some of us are going to say not an e? Because an e won't cancel out, because check out your button on your calculator. This is a base 10. Is that cool? What is e for? No, it's been a while. What is e for? Natural log. Okay. We learned something this year. Guys, okay, coming back. You guys ready? What do you have?
10,000.
X is equal to, careful,
No.
that's 10 to the 1, 10 to the 2, 10 to the 3 is, careful, 10 to the 1, 10 squared, 10 cubed, right? Okay, oh my goodness, like we already solved it, we're done? I didn't write it because I wasn't being very precise, so I apologize, but let me remind you, this is a system. There's my brace. I have an X, that's great and all, but what else do I need? Now, is there symbolism to the pin going straight through the heart, or is this just because it's cute? Okay, I was making sure. Well, it's just, I think it's pierced right in the middle, and I was like, just checking on him, I was just checking on him, coming back. Okay. I just had to make sure he was good. Okay, so we have the 10,000, question 10,000, at least it's not like jaggedly ripped, right? Where does this guy go? Because 10 times 10, which is 10 squared, is 100, times another 10 is 1,000.
Oh, I thought you said 10,000.
Well, the guys were putting some big numbers on it. Just 1,000, just 1,000. Kiddos, where does that 1,000 go?
In the square root
Question. Is this back substituting? I'm going to solve. I just want you guys to ponder what this actually is. And maybe you won't know until we do another example. The question is that actually back substituting?
No.
I'm going to go ahead and plug in the square root. I have 1,000. Plug it in, plus y is equal to 2. What's the inverse of a square root? Squared. And I end up with y is equal to negative 990. Well, okay, I could just box that, but that's not my only answer. What is technically my answer for these books? Uh-oh. Not plus or minus. I know why you said that, though, because there is a square root, right? But question, when I square anything, it's going to be the absolute value. It's going to be the positive version. And it was the positive version of 4, but then what happened? I subtracted. Question, should we check?
Yes.
I would say yes. Now, actually, this answer is going to work out and it is going to be good. If you were to graph this on your graphing calculator, we'll look at that in just a second. This will show up eventually with much window manipulation. But come back. Why am I saying you probably should check? When do we check again?
Oh, that's back substitute.
That's just a step to the process. When do we need to check again? If we have any sort of... So why am I going to come over here and be like, shouldn't we check? Square roots say I can only take what kind of values? Positives. So if I have anything that makes a negative under that square root, it's going to be an illegal or what we call extraneous solution. Ooh. Watch out. 4. What word do you guys hear in extraneous? Extra. You saw this last year. It's not a brand new word. Extraneous, extra. Extra means you were solving in the math and this little extra guy showed up and he was never allowed to begin with. Kind of like, hey, I made it into the park, but I thought I would be able to get them to go in that ride, and they said no. Hey, I have my ticket, but I don't have my vaccination card. Right? Coming back. If I want to go ahead and check my solution, actually, no. If I want to consider whether or not to check, I should look at that logarithm and I should remember, hey, cool kids. Oh, I don't want to get rid of that. All right, we'll just leave it. Quick reminder, square root of anything says, hey, remember, that has to stay say greater than or equal to 0. ln of anything, or any log, fine. Any log of any base says I only accept positive numbers. Square root says positive or 0. Log says positive. Now let's double check. I have a negative. But pause. What goes inside the log?
Only positive.
Only positive. Okay, the log's fine. Cool. What goes? The positive and the negative go under the square root, but wouldn't it be 1,000 minus 996?
Yes.
Which will be positive?
Yes.
Good. Everything's fine. This time. Right? Careful. Just because something was fine this time, does that mean that we should never be careful in the future? No. Some of you are starting to drive. No. We're going to answer that back substitute question in just a moment, but first, let's go play with some other examples. P.S. This one says to check graphically. We'll get to our grapher in just a second. Are we okay?
Yes.
Okay. We're going to check graphically. But cool kids, this is a bit more Algebra 2-ish. Question. If I wanted to use substitution to solve, what do you think we would solve for? Remember, we have to pick. You get to choose. You have a choice. Choose one to solve for one. What do you want to choose? Top or bottom?
I'm missing.
You're going to choose the bottom?
Yeah.
Are you sure?
Top.
Yeah. I feel bad now. Can anybody realize why I didn't want to choose the bottom? I got 2 squares, and so I'd have to do a square root. I had to take that square root and plug into the other one, and I was like, do you love square roots? Then choose the bottom one. I don't like square roots. Does anybody know what I would solve for?
Why? For why? And then there's nothing connected to it.
P.S. Have you read this note yet? Sometimes it's easiest. Sometimes it's easiest to solve for the simplest variable, the one that can be isolated the most simply. What can be isolated the most simply? That guy. So, I'm not saying it's the only way to solve this problem. I'm not saying that in any way, shape, or form. I'm just saying my natural inclination, based on the notes that you just wrote down, would be to solve for y. How come? Well, because y is equal to what, guys? Add the 1 over 2x to the other side, and I have, oh look, it's a line. With an intercept of -5 halves and a slope rise over run of 1 over 2. Hey. Okay, coming back. What do I do with that, though?
Plug it in until the second.
Not back substitute yet. This is my original. Check it. This is my good old-fashioned substitute, right? It's my good old-fashioned substitute. I have not substituted anything yet. I've just solved for 1. Ugh. I have to square something with fractions? P.S. Is this impossible? No. But can anybody think of anything else they could have done? Still avoiding the square root, but also avoiding having to square something with fractions. I told you what my natural inclination would be. What else could you have done? I'm not saying you have to. I'm just showing you options, and then we'll see what's easiest, what's best for you when you tackle homework. But why might I be showing you? Why not solve for the x? Does it take a little more work? Yes. Well, what happens when you're done? Why is it nicer? P.S. Do any of you amazing troubleshooters? Rosters are in there if you look behind. Question, do any of you amazing troubleshooters think ahead in a problem? Maybe we should start. Why? What am I going to do to get this x by itself? I'm going to multiply everything by, we can get rid of fractions. We can get rid of fractions. You've grown now, but you would have grown more when I started foiling something with fractions. Calm down, take a breath, and see if this helps. Because what we end up with now is a positive x equals a positive 2y minus, nope, just kidding, plus 5. What would you rather plug in and square? the 1/2 x minus 5 has? You take the easy route initially and it gets hard later on, or you think ahead a little bit, or take some of what we do in class to heart and be like, oh, I like the non-fraction one. Me too. But it's up to you. So if you guys love the first way, go with the fractions, go with God, and have fun. Everybody else, let's go. You ready? P.S. Not really. It's better though, isn't it? Yeah, you just gotta...
Not really. Don't listen to the haters.
Okay, alright. That was good life advice. Don't listen to the haters. Take that one. Life lesson. Okay, so... P.S. Ryan, what's this step called again? Yes, this is just substitute. We're good old-fashioned. We have something and we're plugging it in, right? We're going to have 2y plus 5 squared. And I'm going to tell you, don't kill a what?
Dog.
Don't kill a dog.
Alright.
What do I mean? Start with an F and end with the oil. Do each and every step. Why? Because this is not 4y squared plus 25. This is 4y squared plus 20y plus 25. Do the math that you need to. Do the math that you need to get that answer on your own. It is not 4y squared plus 25. It's 4y squared plus 20y plus 25. Do the math that you need to justify that to yourself. Don't just take what I say on faith. There is no faith in Misty. Please don't. That is a bad place to put your faith. By God's grace, every now and then I can be right. But I can also be wrong. What are you doing right now to prove that to yourself? Doing what yourself?
Foil.
And how does FOIL work?
4y squared plus 25.
But how does it work? What's 2y times 2y? What's the outer 2y times 5? 10y. But how many 10y's are there? 2 of them. And 5 and 5 is 25. Did you prove it to yourself?
Yes, sir.
4y squared plus 10y, which is 20y plus 25. Woohoo! There he is. Ready, set, solve. What?
No. Oh, here.
Woohoo! Paul's already there. Can the rest of you guys get there? I'm going to have 5y squared plus 20y equals. Are you guys cool and you're canceling out the 25 and getting the 0? Are you realizing it's an easy factoring problem? Come on, my algebra people, have fun. Y plus 4? Woo! How many solutions are there? But why? Oh, why? Why? Good. Never mind.
Does that mean there's multiple intersections?
Solid. What did Ryan just say before I finished writing what I was trying to write in order to make sure you guys understood? That is not the x and the y. Those are two different y's. So there must be multiple intersections. How does this make sense? I don't know. We'll see it in a second. But first, oh my goodness. Thank you for laughing. Okay, coming back.
So you did it the first way. So she switched.
What else do I need? The x's. Ryan, what was that term I said, no, not yet, but now it's time? Back substitute. We have answers for both y. Well, not x yet. Yeah, you're right. Sorry, Paul. I was about to say that, but I'm wrong, right? We have two different answers for y's. My ones that struggle whispering. Work on whispering. Okay, so I have 0 and -4. Still love you, though. Where am I going to back substitute it to? Yes, in your notes. This is what I need to back substitute. And I'm back substituting into my one variable solved in terms of the other. Well, question, guys, where is my one variable solved in terms of the other? X equals 2y. Go back. What you substituted, go back to it. Back substitute. Why? It's the best place. It says, hey, I double the y and add 5. Cool. Double the y and add 5. That's going to be 5. Double the y and add 5. That's negative 3. Go back and plug it in. Double it and add. Double the 0, add 5. Double the negative 4, negative 8, add 5. Haha, I got it. So therefore, x of 0, which is weird, but it is. It's x of 0, like f of x, but it's x of y, is equal to 0 plus 5. And x of negative 4, x of y, because that's my variable, totally valid math notation, is negative 8 plus 5. I have my two solutions. I'm not going to have you check them. How come? Does a line or a parabola restrict domain at all? No. Line says any x. Come on. A parabola says any x. Come on. No square roots, no logarithms, no fractions. I'm good. I'm about to show you the graph of these two guys to have you check it graphically, but I'm curious if you have any idea what type of picture it's going to look like after Jackson's question. We'll see what you guys think of. What picture would this look like? Jackson?
If there's like a square root and you got negative 3, it's called negative 4.
You see how it could be extraneous, but if there was a positive number or like something was, maybe it was y squared plus x, well then it would be fine. But I have to check. Does that make sense? Ryan, do you have any idea, Ewan, because his hand is up, what this picture is going to be?
Maybe like a parabola.
Hold on, let the man speak. Let the man speak. Have respect. Go ahead, Ryan.
A normal straight linear line and a parabola.
Ooh, because that could have two. Anybody want to make any other guesses? A parabola and a line. Oh, we have forgotten chapter 1 so quickly.
We did check.
Chapter 1.
Oh,
Was it
I see.
1.1? Was it 1.2?
Could you say it again?
What do you think this graph looks like? Ryan Union is saying, I think it's a parabola with a line, which could have, I can't show a big parabola, little parabola with a line, could have two intersection points. And I said, have we forgotten chapter 1 so quickly? Paul, what do you think?
Yeah, the square root.
Square root? With a line? That could have two, too. Piecewise? I mean, technically, this would be a plus or minus square root.
Maybe it's like.
If I got y by itself.
Maybe like a sign.
What is it? What's the
Those ones need trig, though. The wavy ones need trig. Good idea. That's gonna swirly ones. That's gonna be in a whole other mode, actually.
The absolute value.
Oh, I don't even have it in the forever cards. I keep on meaning to add it too. I know. Does anybody remember an R somewhere in that?
Radius.
Round. Oh, man.
Circle and radius. What? Where is there a circle? X squared plus y squared is equal to what again?
Is a circle.
Oh no. Oh no. Oh no.
Ooh, that's a nice.
How's that?
Very good.
What? I see a circle. Don't you see a circle?
Yeah, I see some.
But where's the radius?
Oh, it's that one.
Yeah, no, we have to find
Oh,
it.
that's a nice side.
So it's 5. Oh my god.
That's not even fair.
Wait a minute. How is the other one the line? Because it's negative 5 halves. It's halfway to negative 5 halves with a slope at rise over run of up 1 over 2 or up 1 over 2.5. Sorry, I should say up 2 over. Wait, does it cross at 5, 0? Yeah, it does. Does it cross at negative 3, negative 4? Well, I don't know, but now I do. How soon we forget. There's a life lesson in this somewhere. All right, number 22. Ready, set. You guys solve it in whatever way is easiest for your brain. Go. Come on. There are no squares. You're fine. Go. But the question is, what are you going to go for? You're going to go for the easiest initially, but it might be harder later? Or are you going to go for a little bit harder initially, but might make your life better later?
Oh.
Oh.
Actually, he might. What do you mean he might?
Oh, okay. So alright.
Actually,
Oh,
he might.
I know that he works.
Me too.
Brendan's like 5 minutes.
No, it's the second one.
It's the easiest solution.
Oh, that's not.
Wait, are we not started yet?
No.
Oh.
I wrote the problem.
Well,
I figured I got started.
You already figured out why?
Yeah.
No.
if you are one of those that are like, I want it easy right now, okay, go for the Y. Good luck with whatever that does. Go for the Y. If you need it easy right now, otherwise you won't start. If you need it easy right now, otherwise you won't start, solve for the Y.
So put y equals.
Get the Y by itself, right?
Oh.
Maybe add the Y, subtract the 4. If you need it easy right now,
I'm doing the other one.
go for the Y. If you're like, I like to be strategic, and I want to think ahead to try to make it as easy as possible, then maybe, just maybe, you'll be going either for that Y or that X.
Bro, I was doing that.
If you're being strategic, and you're like, I'm willing to think about it and try to choose the best route forward for the future steps,
Dude,
I would advise solving for either the top Y or the bottom X. Yeah.
Okay, so if you're doing the top one, if you multiply the 2 over to make it 20 and then subtract the x, is that legal?
Yeah, you can do that.
Okay.
And maybe, just maybe, a few of you were like, but might this one be even easier than all of those? Maybe just a few of you are like, then again, I don't like the 3. Anybody there yet? Then again, I don't really like the 3. So maybe you'll go tackling the other X. And then maybe, just maybe, a few of you are like, I tried. I think that's the easiest. Long story short, you gotta pick one, you gotta go for it.
you do y equals.
You can do any of them.
Can you do that one?
You want me to do that one? Natalie, are you cool if I do it I want to be as lazy as possible, so I'm doing that?
Yeah, that's kind of
80 over.
Oh. This entire section is called substitution. So the question is there a place for you to substitute that? The directions would say, once you have something, go to the other one and plug it in. Once you have something, go to the other one and plug it in. Once again, for those of you guys being like, but I want it as easy as, maybe you would have done something like solve for this x. Multiplying everything by 2. But you still would have had a nasty fraction. Did anyone realize that there was absolutely no move you could make that would erase all the fractions?
Yep.
It was worth trying, because in problem number 11, I was able to. I was able to get rid of all the fractions. The 3 was a bummer. And the 2 being not as big as the 4 was a bummer. There was technically no way to get rid of all the fractions in this one, but it was a worthy pursuit. It was a worthy pursuit. You would have had to multiply everything by 4/3, and it's like, I don't like the 3. So I landed back at the beginning, not because I didn't think ahead, but because I tried and it didn't help.
Wait, mistakes?
Yeah.
How did you? Oh, you just.
I was lazy. I added the y and subtracted the 4.
The whole 3 over 4x.
I don't like doing the whole multiply by a -1. It's tricky in my head. It's easier in my head to add and then subtract. Yeah, Paul. Oh, you're good?
Yeah, that kind of type for both sides.
You could do times 4, but you still would have had the 3.
Yeah, minus.
Then divide everything by 3.
Yeah.
Yeah. It still would have worked, right, Paul?
Okay.
Oh, I mean, this is
But when I saw the 3, I was like, it doesn't really help. Like, I have a fraction, you have a fraction. It was one of those, like, oh, bummer. I'm gonna go ahead and keep going with my route, but hey, you could have you could have tackled this problem in 4 different ways. All 4 of those ways should work. You could have tackled this problem 4 different ways. All 4 of those ways should end in the same answer. Chris, I'm just gonna start plugging in, but go ahead, go for it, bud. What's up? Chris, go ahead. Oh, you're good? Ryan, what's up, kid? I would suggest not, because it was given to you in fractions. That kind of indicates what WebAssign would want, what about the book. Depending on how messy it is. Let's see, I would have 1/2 plus 9/16. So I could multiply by. I have 13 times 16 17ths,
Yes.
which would be. Uh-oh. Well, I had to multiply by the reciprocal to get it on the other side, right?
Wait. Don't you just?
I had to get a common denominator.
Wait, did you get the 17 over 16?
Yeah, 17 over 16, but then I had to multiply by the reciprocal to cancel it out. Right? Yeah. I have to get I don't want to do 13 times 16 in my head. Say it one more time.
How did you get from the 3/4 or the 1/2 x plus 3/4, 3/4 x minus 4? Like, how did you get to the next step?
I thought about combining my like terms, and to make it to where you guys could follow the math easiest, I got my 9/16 x with my 1/2 x, and I'm like, they're both x's. Let me figure it out, and I'll put it all back together. Another way of looking at it is you could have put the x like at the other side. Like you're combining like terms, but they're nasty fractions. So I think I was trying to make it easier and it made it worse. Sorry, that was a -3. But I saw like the x's and the x's, and I had to put them all together, but they were different denominators, so I got them all combined. I'm just combining like terms. Yeah. So the other way forward, Jackson, would have been 1/2 x plus 9/16 x, and then gotten the common and then put them together. I don't know why I did it like that.
So now do you have to plug in a 208?
What's that snazzy term? Ryan Union, help us out. Back substitute, but yes, Andy, we got to go ahead and plug it in. And say, we have the x, cool, but what else do we need? The y. So y equals, maybe I'll do it up here and then. So 3/4 times 208 over 17. Does 4 go into 208?
I do not know.
It does. Because 4 goes into 25 times and 4 goes into 8 2 times. Well, that's quite nice. 3 times 52 would be 156 over 17 minus, hey, common denominators. What's 4 times 17? 8, carry the 2. 68 17ths?
Yes.
And what's 156 minus 68? Well, 68 minus 56 is going to be 12. Take 12 away from 100, and that would be 88, right, Paul? Woo! Yeah, Andy.
How'd you change the 4 to 68 over 17?
Well, the 4 is naturally over a 1, right? Understood 1? So I multiplied top and bottom by 17 17ths.
Okay.
I just have 88. How do you get 88 over 17? Because I just have 88 by itself.
Well, you must have forgotten about your poor little baby denominator. Because 4 times 17 is 68, 3 times 52 is 156, but 156 minus 68 was all over 17.
Maybe I got mixed up because I did like the first way. Like I solved for x on the top equation.
Oh, it should have still worked. Interesting. So if you solved for x, you would have multiplied everything by 2, right? So then x would have equaled -3/2 y plus 20. And then you would have plugged it over here, which 3/4 would have been multiplied by.
And I got like -9/8y plus 15 minus y is equal to 4.
Minus y would be -8/8y. So then there's your -17/8. Subtract, that'd be -11.
Oh,
Oh, you need to multiply by the reciprocal.
No, it's because I added them. I thought it was just, I thought it turns into -1. That's why.
Oh, does that make sense?
Yeah, thank you.
If you'd gone the other way, you still would have gotten these answers, but you would have gotten the 88/17 and then back substitute to get the 208/17. Hey guys, how would you double check this on your calculator or with a graph? Plug it in where? Oh, I thought you were going to get a y equals mx plus b and you were going to graph 2 lines. Okay, so we're talking about our calculator, so plug it into the y equals. But question, if you're not using Desmos, which you won't have on a test, what do you need to do to plug it in?
Put a bracket. Or a break.
I wish.
You do 2 separate things.
Yeah, but both those separate things, I have no other option than getting what alone? I have to get y by itself. But wait, we just did. Okay, cool. So one of them is 3/4 x, right? P.S. Calculator knows PEMDAS. It will divide first and then multiply, but you can also do alpha y equals -4.
And then you have to do
I have to get y by itself, which would be multiplying everything by 4/3. Multiplying everything by 4/3 and moving the x guy to the other side. So let's see, what would that be? 4/3 would be the y by itself. Cool. 4 and 2.
over 6.
That'd be a, yeah, and then 4/6 would reduce to be 2/3, right? And I
Yes,
subtract it to the other side.
Equals 40/30.
Yes. Good. Let's see. Dun 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 dun. Zoom standard. Boop. Zoom out. Okay. Woo! And then I'd do second, and I would do trace, and I would do intersect, because that's what solutions are. Second trace. Ba-doop, ba-doop. Number 5. Boop. Do you remember how do we answer a question on the calculator?
Second.
No, but how do I answer it? Like, I'm in there, and I've gotten it. How do I answer the question mark? I want to say yes, blue. How do I say yes? Enter. Good. Yes, blue. Yes, red? Yes, red. Guess? Yay, that's the answer. No, it's not. No, it's not. Have the calculator do it for you. But it's not a fraction. What if WebAssign doesn't say decimal? How do I do math frac from here? You guys ready for something cool?
No.
Yes.
Take a breath. Let it out. Here's a trick. Do you remember how I showed you the stow button can make something a letter?
Oh my god. It can make it a line.
Not exactly. I mean, it can, kind of, but... Wait. Natalie, this is a cool trick. I want to use this number without writing down this number because I'm a lazy bum.
Yes, sir.
If I go second, quit, check it. Do you guys see the 12.235? I know that this is not that, but if I hit stow coming from my graph, guess what shows up? Ah!
Whoa.
Just memorize the decimal.
Because everything's dependent on x, like f of x.
Oh.
So now I can go ahead and do math. No, wrong one. Do math frac, or I can do alpha y equals number 4. And say, is that a fraction? Woo, I got it. And then, wait a minute. Didn't I put those fractions, or sorry, those lines in my y equals? Alpha trace says you can also get the y equals and say, hey, I want to know what y of that number is. And I can also do math frac to that. Pause, ask me questions on the calculator. Pause, ask me questions on the calculator. Pause, ask me questions on the calculator. Then Noah, I'll come to you. Guys, it's cool stuff. It's cool stuff. Cool stuff. Ryan. Probably. And, like, for some of these calculations, I don't want you to get it wrong if you know the process, but you just make some mental math mistakes in the midst of a longer.
Where did you plug X to get 88 over 17?
In the math or in the graphic?
In the
Oh, Ryan was going this other route. He actually went the other equation, so he got the y first, but I went this route, got the x, and can you not see it? I took that x, and I back substituted it into that original expression that I used to substitute. And so I did 3/4 times the x of 208/17 minus 4, got a common denominator, and I finally got there.
Yeah, I did that, but I didn't get this.
Well, I mean, I guess I could try doing it step by step also. I would advise if you're checking it in your calculator that you just use the actual function itself and plug in. But I could do it here as well, Ryan, as far as 3 divided by 4 times 208 divided by 17 minus 4 does indeed end up being 88/17.
Yeah, I got that. I don't know.
Something does. Usually, hey guys, this is something I've been telling pre-cal, but I don't think I explicitly said it to you guys. Usually, the fewer steps you do something in your calculator, the less room for error there is. So those of you that like to do like a calculation upon a calculation upon a calculation, hitting enter again and again and again, the fewer times you can hit enter, usually the more concise, more precise your answer is, and the less room for error there is. Technically, Michelle. Yes, Noah had a question first though. All right. Go ahead and no talking on the web. Just kidding. You can say hi, but no getting distracted on there. Okay, so check. Solving. Question. Question. So how would I have put number 11 in? No, would you mind opening my door while you're... Thanks, bud. I appreciate it. And remember, kind of pull the door back on it. It'll stay better. Oh. Does someone need help? Andy's got it. Push it all the way back.
All the way.
Kick it in, and then pull the door back on the...
Give it a good kick.
Well, the good kick doesn't really do it though. Pull the door back on the wood.
It's upside down.
There you go.
How many points does it need? Thanks, Ryan. Good job, Chris. Good affirmation. Oh, Chris can focus. His earplug went out. Okay. Hey, guys. Hey, guys. Hey, guys. I would love to answer Brendan's question, but you guys need to be quiet. While I take a question, I want you guys to get me 5/0 and -3, -4 in your calculator. Ready, set, go. Not with Desmos. In your calculator, get me 5/0 and -3, -4. How would you do that without solving by hand? Brendan, what's your question, kid? Say it one more time.
Top and the bottom, making it so you can just cancel out the x and then cancel.
For the top equation or bottom equation?
Like adding into
Oh, that's technically a whole other system, sorry, a whole other process called elimination that we're technically not doing until section 2. Because we're kind of building again from the ground up with harder equations. But you're right, this is like a basic algebra 1, algebra 2 example that you could just do elimination on. I'm not going to make a big, huge deal about it right now just because it's coming next section. But if you want to do some shortcutting, What Brendan's reminding us is that if you can get the terms to match, you can add or subtract whole equations from each other and maybe avoid some of the substitution work. But once again, just for you to realize, Bud, with some of these more complicated systems, elimination is going to be impossible because we can't make a match. But yeah, solid observation. And yeah, elimination would have definitely been a route forward. Andy.
So when we are trying to find the coordinates or whatever.
Exactly.
So we plug it into y equals, right? So
how many y equals are you going to get?
2.
You would think so. I need at least 2, but why am I going to tell you you're actually going to have 3?
3?
How? There's one.
I did that one.
What was the second one?
Isn't it x squared minus 25? Or just
Technically 25 minus x squared, right? Because I need to subtract the x squared to the other
wouldn't
side.
it just be x?
No, you're killing a poor little puppy.
Oh, yeah.
Because remember, this factors. Hey guys, would you have done the same issue? Hey guys, we make lots of mistakes. We make lots of mistakes.
I did x squared plus 25.
But you have to subtract the x squared, right? Hold on, but can you make this 5 minus x?
No.
Because, Caleb and Noah, you guys tracking? Mistakes can be made here. What does this factor to be? It's not 5 minus x squared. It's 5 minus x times, if you were to factor this, it's called a difference of, oh, come on, guys, we can factor these. These are the nice ones. Don't forget the easy stuff. It's 5 minus x and 5 what? Plus x. Are these a perfect square? No. So can I actually take the square root of something that's not perfectly squared? No. So therefore, I have to keep it under the square root. I am not allowed to simplify that at all.
What happens if you press it?
Well, if I press it, I'll get one of the intersections. I'd have to zoom in a little bit because I'm zoomed out right now. I would get one of the intersections right here at 5, 0. What's the problem? Why is the other half missing?
I don't know what you plug in.
What happens when you square root a squared? You get a plus or a minus square root. I'm being a bum and I'm just saying I don't want to rewrite it, but there's a plus or a minus, and I can't have the calculator do that for me. I need to get y by itself and use what I know about the math. Then I have my full circle.
How do you refer to y2?
Plus or minus, so I use the negative, and then alpha trace lets me refer to y's anytime I want.
Alpha trace.
Alpha trace. Alpha trace says I can talk about y2 and not have to retype the whole thing. So I was just a lazy bum and I talked about y2 without retyping the whole thing. But guys, that would be the exact same thing as if I had just done... It's the exact same thing as if I had just done the positive and the negative. Alpha trace. But it's the same thing. Check it. It's the same thing as if I just typed it all, right? I'm just a lazy bum. Hey, does anybody wonder why it looks like an oval?
Units are smaller.
Do you see it? The units are smaller. It's a rectangle. It's not a square. They're squishing a square amount of units into a rectangular space. Check it. Do you see that there's something called zoom square? If you want, it'll look much more like a circle if you say, hey, make it even. Well, do you know why it freaks out? This is called function mode, and functions have to pass the vertical line test, and the vertical line test says I can have nothing that's straight up and down. What's happening at the edges of the circle? It goes for an instant straight up and down. It's called tangent lines in geometry. We're getting into calculus now. The slope of the circle is infinite. Anyway, you guys don't want to hear all this. Long story short, pixels say I can't go any closer. So it's going to freak out a little bit. It's going to freak out a little bit. If I zoom in, maybe I'll be able to see this 5, 0 hitting, but probably not, because it says I can't go straight up and down. You're in function mode. Now it's showing where it's getting closer and closer to, but a heads up, that intersect feature is not going to work because the pixels freak out there. However, it is going to work at this clear intersection. So it's actually not going to get you the 5, 0, but it will get you the -3, -4. As long as you say, yes, blue, yes, not red, I need black. I need black. And then if I go around, round. Is the calculator always the easiest way to solve? I don't think so. That was a mess. But at least you do have a way of double checking. Oh, did it get the 5-0? Did it get the 5-0 for you?
I'm not sure.
Oh, I'll try. I mean, maybe I'm mistaken. I don't think it's going to get the 5-0 because of that going straight up and down thing. But I can try. Oh, stink. I want the blue. Blue, please. Yes. Let's see if it gets it. It's probably going to say no sign change because it doesn't go above and below. But let's see. Oh, it does get it for you. Interesting. He's better than I thought. The upgraded OS did help. Okay. So we've had to use the plus or minus square root in order to solve for that, and I showed you a couple tricks along the way. Let's get back to getting out of that and getting out of that and getting back here. Cool. Hey guys, all I have is like examples to end off today. Cool. Let's see what else we can see. When this one says, hey, it's a good day. What do the directions say for number 43? Ooh, does that mean on my calculator or by hand? Sure, you guys do that thing and then I'll do it by hand and we'll see if we agree. Remember, get all your y's by itself. Do you remember this is a circle with a radius of 5? Hopefully getting y by itself. It happens.
I'm just not cooperating. I'm so
You guys got it?
it's not letting you do alpha y.
Now, I kind of cheated a little bit and it ended up being nice, so I beat you. It didn't have to be nice, but I was like, I want to get rid of the 16 to get a nice number. I wonder if the nice number is the intersection. I saw that 4 squared was 16, and I was like, hey, what happens if I use 4? I get a y of 3. Does 4, 3 work in my first equation? It did. I just found what I hoped was a solution, and it worked. However, technically you were allowed to be using your calculator on this one, so you guys hopefully were putting in, hey, can I leave the plus or minus 25 minus x squared square rooted? Yeah, it's the exact same circle. But then I would have to put 3/16 x squared as my other equation, right? I could go ahead and graph. Then I could use my second trace and my intersect feature, which is number 5. I would want to use blue and red because it does not intersect black. And if you guys see symmetry, I only need one because then the other one will be mimicked with a -4, +3. Dun, 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 dun. But Natalie, what was your question on your grapher?
It's not letting you do alpha y equals. It's not doing it.
Really?
Yeah.
What happened? Like from the home screen or from the... Try the home screen just to see.
No, the home screen works, but
But not the front.
It works for me. Wait, when you're on the graph?
And you're off the equal sign, right? Like you're actually in the...
Oh, yeah.
You're not like on the equals? Do any of the other alpha, like alpha window, alpha zoom, do any of those work? weird. I mean, technically you don't need it, because PEMDAS will divide and then multiply.
I mean, yeah, all the other ones.
Huh. Let me see where you're typing it. For everybody else, P.S. So what would you do for the next example if it also said, if it also said, use your graphic? Those of you using Desmos, remember, what are you guys doing? Analyzing the problem. Okay, cool. I can do that.
the LN now.
What? I wouldn't do LN because it's already written as a nice little like, hey look, it's a swoop. It's Y by itself. Exactly. And then TBH, this one's not too hard to get Y by itself. Although I'm a lazy bum, I would add the Y to the other side and just get my X plus 1. That's kind of cool. E to the 0 is 1, if you guys remember your special points of your parent function. This has an intercept of 1. Question is, what does the rise over run of 1 do? Question is, what does the rise over run of 1 do? Which is why it's having you use your calculator. Some of you are already seeing it. For those of you that aren't, you know how to put this in your calculator, right? Throw in that nice little e to the x to get your swoop. Throw in that x plus 1 after you get that y by itself. Ooh, what's so snazzy about this line and about this curve? Sweetie, any idea why I'm going to be all excited about this example? It is an exponential. And what's so special about this line? If it skims it at one point.
I forgot the word.
They should know it from geometry though, right? Help them remember the word. What's that word of a line that skims a curve in one point, but back in geometry it was only circles, but now we know what happens to anything curve? Is that it?
Yes.
Tangent line. Hey sweetie, is that important in calculus? Very. Tangent lines. Those are important in calculus. Don't groan. It's not as bad as you think. Well, depends on the day. Depends on the derivative.
She said well, so you know.
But it's really just a line, and guess what? Oh my goodness, it's a good day. Because, you guys ready? Let's see, where is it at? Oh no, where is it? Well, I guess he's busy right now. Well, obviously I don't know what card it is. Where am I putting it? Yes, Ryan, all of these are derivatives.
Oh.
And these are derivatives.
Why is there so many?
And these are derivatives. Well, because you have so many different types of functions. Those are derivatives. Those are derivatives. Hey, logarithms. Those are derivatives. Those are derivatives. Those are derivatives. Oh man, where am I tangent line? Well, that was anticlimactic. I don't know where they are. They're hiding. Well, I guess I switched it into another card and I forgot. Right here, finding the tangent line equation of the tangent line f of y minus y1 equals m times x minus x1, but there's a funny prime in it. And anyway, this guy that you see. Anyway, don't make me start to have all of you pull all of your nice playing music devices in your ears out of your ears. Because there's one there, there's one there, there's one there, there's one there. There's actually quite a few around the room. And I give a lot of grace, but if you don't quiet down when I'm ready, whoop! I was pointing to Andy. Coming back.
Get exposed.
Coming back. Well, some people are super obvious, some people are not. I just want you to know I see you. Focus. I was talking more to this side of the room. This line thing that has to do with this line thing with a derivative that Ryan introduced today because of his cousin and a conversation they had, that's exactly what this guy is, and he's so important in calculus. Because he says, with our calculus skills, that we are able to figure out an instantaneous slope and rate. Anyway, all these things that are interesting. But long story short, how many times does this line intersect this curve? Once. And all of a sudden, you've seen one of your first tangent lines not to a circle. Has a lot of implications. But long story short, there's only one intersection point. And what is that one intersection point? Well, isn't it right here where they hit, and where they hit is 0, 1? Dun, 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 whoop, whoop. And that's what you would have gotten if you had done the point of intersection. Okay, anyway, tangent line, that was fun. Let's keep going. What if we have words? Oh, we should sue. What if we have words? No, don't sue. Okay, come back. I know, I think you should. Just kidding. Words. How does this belong in substitution? Thank you. Yeah, maybe not. I don't know. I noticed it when you went to the bathroom. I was going to tell him when he came back, and then I forgot. Come back, come back. Why is this in the substitution lesson? Okay, ready? We should probably talk about this. We should probably talk about this. Shh. We should probably talk about this. I'm trying to help you with homework. Okay, so break even. What does that mean?
The profit and the money spent for the profit.
So I'm making money, right?
Yes.
So money coming in, money going out, money already in. Right? Okay, so how much money do we start with? Cool. So you have an investment of $16,000 that's supposed to get you off the ground, true? What else do you have? You're making $55.95, and you're hoping to sell some, right, kids? You're hoping to sell some. However, don't you have to pay to make some to have them available to sell first?
Yes.
Unless you're doing it at the Etsy shop, and maybe you make it as they order it, but that could be dangerous if you get a lot of orders. Anyway, long story short, how do I make it break even? What's going in equals what's going out. You're spending, and you're really hoping. Most businesses are like, where's the break-even point? Because right now I'm in the hole, I'm in the hole, I'm in the hole. Hey, I'm making profit. Really important thing in econ, PS, second semester, senior year, have fun. But, how do I solve? Why is this in this section? Well, technically because this, guys, is one equation. We just didn't say it that way. And this is another equation. One is for cost and one is for profit. And for break even, we say, let's go ahead and solve the system of equations for the cost, and let's go ahead and solve the system of equations for the profit. So if I wanted to, I could go ahead and we're making money here, or having money coming in, and then we're spending money there. So it's a system because technically you're solving, but I mean, isn't it as easy as get x by itself? Is it going to be a big, big, big deal? No, not as long as you know what you're doing. So then x is going to end up equaling, isn't it going to be, let's see, be efficient with your math, right? Be efficient with your math. Isn't it going to be 16,000 divided by 55, 95 minus 945? So I'm going to combine my terms. I'm just being lazy and I'm going to throw it on my calculator all at once. But does anybody realize that technically the way I have it written, there should be a negative, but I don't really want a negative because that doesn't make sense? Okay, so what's wrong with what I wrote? Where's the negative that should be there so that this isn't a negative? Because if I subtract right now, that's a negative number, and that means to sell a negative number, which makes no sense.
Negative X.
Oh, the 16,000.
Isn't it? Like,
But I'm adding money, but this one's a negative. Why, Johnny? Because it's cost. Yeah, if I'm trying to make them equivalent, I can't say that cost is equal to profit. I mean, I could say something like maybe absolute value. Maybe absolute value. But cost is money going out, and so in math we would make that as a negative. Then we could subtract. Wait, no, that's not right. Wait a minute.
Isn't it easier to subtract 5.95x minus 9.45x equals 1600?
Oh, we're not even close to getting these. Well, I know we are, but like, really.
Oh, I guess you could say investment. But I want the cost and profit to be equal. No, I see what you're saying, like change up my system. Anyway, guys, we are just doing examples to help you on homework. I will see you next time. Happy nutrition.